But we quickly ran into a problem, and maybe some of you describe perfectly legal drone flights or things that probably weren't drones at all. In Europe, EASA has its own database, but that data isn't public, so we can't independently evaluate it. And even EASA itself cautions that some of their drone sightings, especially the ones at higher altitudes, probably aren't drones. We also looked at the UK Air Prox Board data because their reports have a reputation for rigorous investigation. But their drone sightings still depend on the word of an airplane or helicopter pilot. And that's true even if those sightings are wildly implausible. It still gets counted as a sighting, and the data is not useful. So trying to learn about drone safety from the data really was not informative. And of course, looking at news stories is even worse. There are lots of claims in the news about drone incidents that probably never involved a drone. Here's a few of them that were confirmed not to be a drone. Even collisions, pilots reporting a collision with a drone, are actually not reporting drone collisions. We counted 6 reported drone collisions with airplanes that turned out to be caused by birds or bats or something else. And here's a sort of a poignant example. This is from last year in New Zealand. A broadcaster crashed a small plane after saying his windshield shattered in flight. He was all over the national and international media saying it must have been a drone, and a certified flight instructor who was on the ground, not in the plane, said yes, this was a drone for sure. Now, a year later, the scientists come back with their investigation and they conclude the windshield had a critical structural weakness and it never hit anything. Now, this situation is frustrating in several ways. First, because we all know intuitively that not every reported drone is really a drone. Even the sharpest-eyed pilot can have trouble identifying something in a split second that passes by a windshield. And if it happens when the headlines are all about drones instead of birds, it can't help but have the effect in the media. Mythical drone sightings and even those collisions end up feeding media stories that frankly demonize our industry. And most frustrating of all, and I hope you all appreciate this, those stories focus attention on trying to solve problems. And as we look deeper into the data to actually try to understand what could we do to make a difference, we saw a trend that seemed meaningful and that we didn't shy away from. There are no proven collisions between a drone and an airplane, like in those news stories, but there have been 3 actual proven collisions of DJI drones with helicopters at low altitudes. Maybe you know some of these incidents already. The first was in New York City. A drone pilot flew his drone in a temporary flight restriction. Actually, it was a United Nations temporary flight restriction, of all things, far beyond his visual line of sight without understanding the flight regulations or risks. An Army Black Hawk helicopter hit it, fortunately only causing minor damage to the rotor blade and no injuries. DJI assisted the NTSB in this investigation. The second incident in Israel, a helicopter pilot and a drone pilot were each flying professional jobs, operating in compliance with the rules, and they still collided. Neither one saw each other. This was an accident, and again, fortunately, no one was hurt and the helicopter landed safely. Third, in Switzerland, a drone pilot who was maneuvering out of the way of 2 helicopters collided with a third helicopter that was approaching from behind. Now, this is what was left of the drone, and thankfully, again, the helicopter had minor damage only and no injuries. And we came across, in addition to these actual real collisions, we came across 2 troubling videos of operators apparently using our drones that inadvertently came dangerously close to helicopter traffic. The first was a video on YouTube of Hollywood, Florida. Here's a screenshot of that one. And then the second near Niagara Falls. The operator here in Niagara Falls seemed especially remorseful in his own comments on the incident. He wasn't aware of the helicopter. And the lesson from all these real data points is that drone pilots flying at low altitudes need enhanced awareness of other air traffic. And all of those long-standing safety features that I mentioned, like geofencing and altitude limitations, those aren't enough to address these risks. So we thought about that, and we realized we actually had the power to do something about this real risk. Our professional drones, like the M200 and the Mavic 2 Enterprise, are already equipped to receive ADS-B signals using our professional safety feature, which we call AirSense. But there are many, many, many more consumer drones than there are professional ones, and perhaps, I would guess, 10 times as many. And the people who buy and fly those consumer drones, which tend to be smaller and simpler, they could really benefit from ADS-B, especially after January 1st of next year, when the FAA will require effectively all airplanes and helicopters flying in controlled airspace to broadcast an ADS-B out signal. And once we looked at it that way, we realized what we had to do. And so in May, as some of you may have heard, we announced our commitment to doing it. Starting next year, DJI will install ADS-B receivers, ADS-B in only, in every new drone model that we release above 250 grams. Now, we're taking existing aviation technology that helps pilots avoid collisions, and we're putting it in drones that you can buy off the shelf at an electronics store or online. So pilots, drone pilots, will be automatically alerted when that traffic is approaching and the location of the drone relative to that inbound traffic. They may even get that alert before they can see or hear that approaching traffic. Putting ADS-B in new DJI consumer drone models will immediately become one of the biggest single deployments of ADS-B receiving technology in the world. And just to be frank with you, we're not actually sure we know how we're going to do this. Squeezing an ADS-B receiver, which is new hardware, into small consumer drones isn't easy. We're actually being pretty aggressive with this goal, and we've had to revise our plans for models that are already in production. But we want to be ambitious, as we always are, and actually try to do something to address this risk. Now, just as we challenge ourselves in that way, we also believe DJI can't act alone on safety efforts. We really all need to work together. And that's why this summer, we released a white paper called Elevating Safety that outlines our vision for ensuring the sky stays safe in the drone era. There are copies out at our booth, and you can also download it electronically at that website, our FlySafe website. Now, this describes 10 steps that must happen, we feel must happen, in order to address and ensure drone safety and to protect drone innovation so we don't end up with that public distrust that undermines the beneficial operations. And the first of those 10 points is our ADS-B commitment, which I've described, but we're also doing two other things. We're creating a flight distance warning. This is to help pilots remember that when they fly far away, they may be leaving visual line of sight and creating additional risk, like in that New York collision scenario. And we're also enhancing and expanding our safety standards group internally in the company to focus on other ways to improve safety. Now, these are our commitments, but we also believe others in the industry must step up and do their share, including developing standards for reporting drone incidents. So aviation groups that I think a lot of us participate in, we really need to work together and figure out how to validate and understand these reports, which ones are real, which risks are actually reflective of what is happening, and move forward from there. We also believe that other manufacturers have a responsibility too. If you are selling a capable drone technology that has the ability to navigate in a sophisticated way, you should install geofencing and remote ID. It's not about regulations or mandates. This is not a policy initiative. This is proactive safety measures that we can all implement right away. And our partners in government need to step up too. They need to focus on the policies and solutions that will make the greatest difference now. We've talked about this in other sessions today and yesterday. This includes remote ID. Security agencies need to be able to identify and track airborne drones as well as their pilots before they will allow many other expanded uses for drones. And that's true around the world, not just in the US and EU. And this is really an area where consistent global actions and standards are needed. And I'm glad that this week, as you've probably noticed with those cards, we're demonstrating remote ID in its standardized form developed at ASTM International. I'll talk about that more in a minute. But also, we need knowledge testing. So governments need to require a user-friendly test for people to understand what the rules of safe operation are. And that may be counterintuitive. Why would a drone company want to impede a sale by requiring a knowledge test? But we've already imposed that in our own technology, and we really have seen that it's a good idea, and everyone needs to know what the rules are. Number 8 on the list of 10 is governments really must designate the most sensitive areas where drones shouldn't fly without special permission, such as prisons, government compounds, military bases, places like that. Now, we'll certainly advocate for the least restrictive and most clearly necessary restrictions for drones. We really don't want to impede the actual innovation out there. But everyone needs to have certainty about what areas are strictly off limits, and that's also something that we can implement in our geofencing to help provide a technology-based solution to those policy determinations as well. Now, when a drone appears to truly present a clear threat to safety, such as at an airport runway or an overcrowded stadium, we believe local authorities must be allowed to take action. Right now, in many countries, they don't have clear authority. They don't have the tools, the training to respond the way they would to a similar threat that's on the ground. So it's really important for us to provide that in those rare cases when action is needed. And finally, it's really important to keep in mind that even the best drone laws and regulations don't mean anything if they're not enforced. Through our work with government agencies, we know a small number of drone pilots around the world have been caught doing extremely unsafe things, sometimes deliberately. And it makes us sad when we see that. But they rarely seem to face punishment. We need to see more deliberate, unsafe flights punished, even if just for the deterrent effect. And drone pilots who follow the rules need to see that as well, so they'll have confidence that the rules that they follow are worth following. And of course, the public needs to see that enforcement as well, so they'll understand that there's accountability for those types of drone operations. Now, these 10 steps are a lot, I know, and they don't come without a cost. They'll impose burdens on us and on drone pilots, the industry, and of course the government that oversees them, but we believe they're worth it. Drones do already have an admirable safety record. We want to maintain that and even improve upon it. And so that even people who will never fly a drone, and most people in the world will probably never fly a drone, they deserve to know why drones are a safe addition to the skies. Now, finally, we want to hear from you. Tell us what we can do, not just here this week in Montreal, but beyond. Is there something else we haven't thought of yet? How can we work together on other safety enhancements? DJI is really privileged to be in a position to deploy safety solutions across the vast majority of the market, pretty much overnight if we push to get it done. Help us make the most of that opportunity by working with us. Now, at this Drone Enable, I have 2 closing requests for you, things that we can do soon. Between this Drone Enable and the next one, please consider the benefits in all of your countries as to ADS-B out for manned aircraft. Once most drones have ADS-B in, there's a clear benefit to a collaborative environment where there's more ADS-B out. And ways to incentivize that existing technology to solve challenges would be terrific. A colleague at another company refers to ADS-B as drone repellent. I thought that was a very smart way of putting it, but it will work best if there's collaboration. And second, and finally, please come to our remote ID demo tomorrow at 8 a.m. at Bonaventure Park. It's just down the street here, a 3-minute walk. You'll get to see how existing technology that's already in your pocket, your phone, can provide a remote ID solution free of cost to the operators who will need to comply. I really look forward to continuing these conversations. Thank you very much.
Thank you very much, Brendan, for your presentation. As a practical reminder, I would like to encourage you to submit your questions at any time through email at the following address, plenary_1@icao.int. This afternoon, we'll continue with our RFI theme. And the first session will focus on issues of UTM risk assessment and contingency operations. The moderator for this session will be Mr. Chris Dalton. Chris Dalton is Chief Airspace Management and Optimization Section in the Air Navigation Bureau at ICAO headquarters. In terms of standardization, he is responsible for annexes related to the rules of the air, air traffic services, search and rescue, and various aspects of communications and surveillance. Please, ladies and gentlemen, join me in welcoming Chris Dalton. as well as his panelists, please.
Thank you very much, everybody. I want a special thank you to all those of you that are coming from the other side of the world. I just flew in from Bangkok, so it's 2 o'clock in the morning for me, 2:05 in the morning, okay? So we're going to get through this together. And special thanks, please, to the presentation of Mr. Schulman from DJI. What an excellent start for the afternoon. The gentleman that you mentioned in one of those articles, I've played golf with him, that Rod Vaughan that misidentified the accident. I know him, I'm just saying. Fantastic panel we have here, and without further ado, you know the bios are on the website, so I'm not going to give detailed bios for these gentlemen, but the subject is risk assessment and contingency operations. We will focus on key principles of UTM risk management and clarify what should be considered when establishing a UTM risk assessment model. Without further ado, I'd like to introduce Mr. Nico Vorbak, Director of ICAO Affairs, Kenzo. Thank you.
Thank you, Chris, and I would like to thank ICAO for inviting me to speak on Drone Enable. So, first I would like to talk a bit about Kenzo. For those who doesn't know, Kenzo is the Civil Air Navigation Services Organization representing 92 ANSP members, which are more than 90% of the world traffic representing. And we have also 91 associated members, and the associated members are members that have a business on providing services or equipment to ANSPs, to the air traffic management organizations. Also, we have some UTM providers and some drone operators as our associated members. So we try, as the representative of air traffic management, to see how we can integrate the new entrance of drones into the ATM world. So we have a network of ATM because of our membership, and we try to get that expertise around the world to fora like this, but also to the governments to know what they should do on the ATM and to keep everything safe. For the drones and the UTM, we have a special UTM task force within Kenzo where we have the experts from the air traffic management organizations, but also from UTM operators to see how we can enhance the safety and the interoperability of the two systems. Our core principles are, like everybody here, safety is paramount. We have a safe system. We want to integrate this new system of UTM, of drones, of RPAS, but it has to be safe, and it does not have to it should not deteriorate the safety levels that we have at the moment. Perhaps it should even increase because we have more and more traffic. If you want to integrate it in a good way, you have to have an interoperability with the ATM systems. So whenever there is a possibility of interaction between drones, RPAS, and the conventional aviation, there should be an interoperability that we can see those two conflicts and how to resolve it. But also other speakers have already spoken about that. So if we talk about risk assessment, we have to make sure that new services are considered air navigation services. It is a air navigation service, and UTM is an air navigation service, so it should be working more or less the same. However, we know that UTM uses new technologies, is more automated, so the conventional ATM system can learn from that, but we have to be sure that it is interoperable. Another thing is, we talk about safety, but it also should not impact the current operations, because we know that in the coming 15 years, aviation will grow with 100%. It will double in 15 years, but the drones will even go further. And we have to make sure that there is a way to make that efficiently work and not deteriorate the flow of traffic that we have at the moment. Let's talk a bit about risk assessment. What is risk? Risk is a vulnerability that you have and the impact that comes out of it. So if we talk about the risk for drones, it's not just talking about a drone colliding into another drone or a drone losing control. It's also the whole system that might fail. And what do we do with that? A big risk is if, for example, a GSM telephone company just shuts down and we have no connections to a lot of drones. Or if the UTM system have a blip and the whole system stops. So if we look at risk assessment, we have to look in a wider form. We also have to look at weather. What if the weather deteriorates inside an urban area? What if we suddenly have wind velocities that make sure that our drones are not able to stay in the track that they are doing? That is the risk we should look at as well, and not just collisions or loss of control. Going then to contingency planning, if you know the risk, you have to plan for it. You have to have a contingency to deal with those things. To recognize it, we say, and as we see from our previous presentation, that we have a ADS-B in for the drones so that they can see. But what do we do if a system fails and we don't know where the drones are going? So we need to also have a system in place that ATM or the conventional aviation can see if a drone goes rogue or goes somewhere else. How do we deal with that contingency if it's not just one drone, but as I said before, if the whole system collapses and we lose a whole system of drones? Perhaps not now, but if the expansion of drones is going as we all hope and all foresee for the future, the problems could be more. So we have to look into those contingencies. We have to look, how do we deal with those problems? Loss of a GPS signal. We know there are areas where there are GPS jamming. We know there is sometimes loss of GPS signals. We have to deal with that as well. We have to have a contingency for it. Perhaps in the drones it should be included that if they lose a GPS signal that they just land. Something like that. We have to start thinking about big contingencies and what we do. Talked a bit about weather before, centrifuge effects into urban areas, updrafts, downdrafts. How do we control the drones? Do we need a system where there is weather alerting, where drone operators or UTM system providers know that the wind is increasing, that they know that there is a problem, that perhaps the drones cannot stay within their current tracks, that we have to have a contingency for that. We talk about lost link. We always talk about lost link. If one drone loses its link, we have to have a contingency for that. We as Kenzo are promoting within ICAO a special squawk via ADS-B 7400 that an ATM operator knows that a link cannot communicate anymore, that there is a lost link. It's another contingency that we have to build in. To conclude, I don't give any solutions, but what we do today, what we do in the future in areas like this, will change the future of aviation. We know that, we see that. And therefore every stakeholder has an important role to play. All of us have an important role to play. And by working together, on a very structural way, we will be able to move further, faster, and safely integrate UAS in our airspace. So let's do it together, but look at the future, look at the growth of aviation, look at the growth of the drone, and start our risk assessment, and after that our contingency planning, also for those big solutions and not for the smaller problems only. Thank you.
Thank you, Nico. And he's set the rules for sticking to our time. Actually, I was speaking to Leslie before. She's extremely pleased with everyone actually sticking to their times for their presentations. So thank you for that. Our next presenter is Mr. Peter Sachs. He's the Safety and Risk Architect for Airbus UTM. Peter.
Hi. So I'd like to talk a little bit about how we can calculate risk for a given flight, and what does a given risk assessment tell us, and how do we learn to trust those results? Little spoiler alert, we haven't solved all the problems yet. So Airbus UTM is building digital air traffic management solutions to enable the next stage of aviation. When we talk about UTM, this is not just low level, although that's certainly where a lot of the demand and problems are. But done correctly, these are services that we should be able to scale and build and certify to support a variety of other things as well. So urban air mobility that may cruise at 1,000 to 3,000 feet, high altitude pseudo satellites, even services that can help in conventional aircraft operations. So risk management today, as you all know, is very human-centric. We've proceduralized a lot of it to identify hazards and risks and mitigations ahead of time. And we've standardized a lot of our workflows when something does go wrong. When I was a controller, we talked about normal emergencies on our end. An aircraft that had a hydraulic failure, we had a certain set of procedures to do before, during, and after. And usually the fire trucks came out and stood by the edge of the runway, and the pilots similarly followed their procedures to result in a safe and uneventful landing. This may change in a UTM setting. Remember, we're talking about replacing or pulling the human out of the loop. And to do this right is going to have to be stepwise and incremental and very carefully tested. So pre-flight, we can do risk assessments minutes, days, hours, months in advance. The things that we are assessing are a little bit different depending on the time horizon. The key here is to help the operator plan a flight that will be safe, and then when they're ready to take off, make sure that they're actually operating in a safe way, given temporal constraints, what's the weather right now versus what I thought it would be. In flight, those same services can continue to monitor what's happening. This is often referred to as conformance monitoring. It's not just, are you a little bit left or right of track? Is the battery draining the way you expected? Is there more of a headwind than predicted? And do we need to do something? And of course, in an emergency, these same services should coordinate with each other, and as Nico mentioned, coordinate with the overlying air traffic management so that the humans who are involved understand what's happening, so that we don't cause a follow-on new emergency with a poorly executed contingency plan. So I'd like to step through briefly 3 different methodologies to sort of illustrate the state of where we're at. And to be clear, this is not, this is about understanding what each of these methodologies are designed to tell you, and they're not designed to tell you everything. So consider just a simple inspection flight. I picked an area near my home in San Francisco. This we'll assume it's VLOS, even though it's actually several miles, but it needs to inspect a couple of construction sites and cross a very busy freeway to get from one to the other. And it's within a Class B surface area, but about 4 miles from the airport. So if you do a SORA very basic analysis with this, you will find that this is a SAIL 6 mission. SAIL 1 through 6 characterize ground risk and air risk in a qualitative way. The main reason this is SAIL 6 is because you're in the Class B surface area. Additionally, there's a couple of fairly dense neighborhoods that you fly over that most regulators, I think, would characterize as populated. We're in the city limits. This is not a rural area, so that increases the ground risk. To fly in this kind of an environment, the operator would need to meet very stringent requirements set by the regulator. They may need to have independently verified maintenance program, training program, a variety of services. Remember, of course, SORA is not your flight authorization. This starts that conversation to make sure that you have all the right processes and controls in place to operate in this kind of a venue. From our discussions, and I'm sure you've had similar experiences in the room, this is not a 1-hour process. This is a couple weeks or a month or 2 or even 3. So LANCE in the United States is a fairly quick and streamlined approval process for pilots. And so you can click on a map using a platform from a variety of different vendors, including Airbus UTM, and get your approval if you meet the constraints. LANCE tells you, hey, you're approved to fly here. Why? Because you're below the minimum designated safe altitude. LANCE is focused on minimizing mid-air collision risk with conventional aircraft. LANCE does not take into account ground risk. That's all baked into the Part 107 regulations that the pilot has to follow. So there's still an onus on a pilot to make sure that they're flying visual line of sight unless they have a waiver, that they're flying during the day unless they have a waiver. So LANCE by itself, we all talk about it as an automatic approval process, but it assumes the pilot is doing a variety of other things behind the scenes to remain compliant with their authorization. So we took a different approach. We wanted to look at this probabilistically and try to tease out some of the different factors that are here. So when we run our own calculation on this, we look at 5 primary factor areas. Things like your maintenance history and the weather conditions when I happen to run this calculation and the pilot's operating experience all check out okay. It wasn't a particularly windy day, it was clear skies. That's great. Your air risk is something that might need to be looked at. We quantitatively calculated an encounter rate on the order of 10 to the minus 4 encounters per flight hour, and that's actually fairly high. That is something that if Lance didn't exist, if this was in an environment where you had to get approval, that's a discussion for the operator to have with the regulator if that's an acceptable risk level. The real problem, though, is that you're flying several miles on a single vehicle. And we've analyzed several 100,000 vehicle flight logs to build fairly precise battery drainage models. So based on the starting voltage, and this vehicle was this was an Inspire 2 with 2 battery packs that were mostly fully charged, you would actually crash about 2/3 of the way through the flight. So Sora correctly indicated a high risk level. Lance said you're good to go. What have we come up here? We come up with 3 slightly different results, and none of them quite captured all of the risk. Nico mentioned a few other factors that are worth taking into account. We didn't look at GPS or comms link. So let's talk about ground risk a little bit more, because this is pretty interesting to me. Right now we're using Landscan. This is commercially available data, and it's a 24-hour aggregate based on census data, people movement patterns, and it grids up the entire Earth into these squares that are about 1 square kilometer. So that's a useful baseline, but it's not capturing really how people move over the course of a day. San Francisco has a population of about 800,000, and on weekdays, about that many more people commute into the city. So the population effectively doubles during certain times of day. Wouldn't it be nice if we could start to capture that? And by the way, to do this analysis correctly in almost any schema, we need to be able to differentiate numerically between what's sparse and what's populated. Is it a number of people that are exposed? Is it a people per square kilometer, per square mile, per block? We do need to do some work on that. So what I'd like to show you here is some development work we've done in partnership with Here Technologies. I think we'd all like to be using real-time cell phone position data, and it turns out that's actually fairly hard to do. With Here, we've been aggregating several years of cell phone pings and time binning it by hour of day and day of week. So what you get is some people movement patterns that you can see with greater detail. You can see traffic on the Bay Bridge at the upper right that changes during rush hour. You can see people move in and out of downtown. I've had discussions in the past with some of you about how do we know if there's boats on the bay? Well, there's a pretty popular ferry route between Pier 39 and Alcatraz, and you can see that show up at the sort of upper middle part of that. So we're capturing a lot of variation, and you can see that San Francisco actually has wide variation through very dense areas downtown and the sparser residential neighborhoods in the west. The other thing that's not here, that is a big open problem for, I think, a lot of us, is how do we accurately capture shelter factor? Not all these people are outside. At commute time, some larger proportion of them may be. Do we use a common value that we agree on, or do we do some additional analysis and modeling on top of this? So to conclude, this has been very vehicle-centric. We can calculate ground risk, we can calculate air risk, we can calculate your battery drain and figure out if the winds are going to be below or above your tolerances for your vehicle, but we can't do this for very much longer. None of the methodologies that I looked at take into account encounters between 2 UAS. As we increase those traffic numbers, there will be increasing risks, not just for the operators, but for conventional aviation and for people on the ground. So we need to look at this very holistically. And if some of those vehicles or all of them are relying on UTM services to, for example, help them route or fly during a period of low population density, what happens when one of those services fails, or possibly worse, gives you a result that is erroneous, but you don't know it? So a call to action is we need to work toward a common risk assessment methodology that can go into something like the ICAO UTM framework. If we're endorsing many methodologies at once and all of them are looking at the risk picture in slightly different ways, there is a risk that we will end up sacrificing the safety of our skies by not capturing those risks completely. Thank you.
Thank you, Peter. Very interesting. Next speaker is Mr. Andrew Carter. He's President and CTO of Resilience, and thank you very much, Andrew.
Well, thank you, and thank you for having me today. It's a pleasure to be here. I really enjoy a good origin story. I liked Mark's story earlier about Unify and some of the early conversations that they had, and I'd kind of like to tell you one of our own. So I was the architect of the U.S. Army's ground-based sense and avoid system. For about 10 years, we worked on this system, and the goal was to get routine beyond visual line of sight operations for the U.S. Army drones in the FAA's regulated national airspace in the U.S. And when we were working on the system in about 2012, the system largely looked like the UTM industry does today. We had the software working, we had the hardware working, we had the algorithms working, we kind of had everything integrated together. And we brought this system to the FAA and asked for approval. And they asked us some really hard questions. They said, well, it looks like you've solved the technical challenge, but how do you know everything's working correctly? At the time, we thought we had a great answer to this. We said, we tested the crap out of this thing. Well, the FAA just kind of got a little smirk on their face. Back then, they weren't as enthusiastic about integrating drones into the airspace. And they said, well, that's how you know it was working yesterday, but how do you know it's working right now? And we didn't have a great answer to that. And then they asked us, and what do you do when something goes wrong? And we didn't have a great answer to that either. So we spent the next 3.5 years trying to answer these questions to a level sufficient that the FAA would allow us to integrate into the national airspace. In 2016, the system was deployed, and it's in use today, thousands of flight hours, routine beyond visual line of sight operations. That didn't show up. So what this leads to is these capabilities that we refer to as in-time system-wide safety assurance. If you were in the USS groups earlier, you might have heard the concept of a system-wide or a safety management system. The in-time system-wide safety assurance or ISSA capabilities are really the real-time element of that safety management system. In 2018, the National Academies in the US put together a report for NASA and the FAA trying to direct their research of what the next steps in safety management of the airspace would be. And they came up with these capabilities. That actually ended up becoming a NASA strategic thrust, where they really looked at with the new entrance of eVTOLs and the new management systems with UAS or UTM and UAM coming into the airspace, what was going to be the next steps? And there used to be a beautiful quote from the paper there. And so really the ISSA was built on 3 pillars: monitor, assess, and mitigate. And so they laid out this roadmap that said, first we have to be able to monitor the system. We have to be able to collect the data, and we have to have enough data that we can do something with it. I think it was mentioned earlier that more data is not always better. When you're trying to predict and detect and monitor, more data usually is better in this scenario. So then assessment, at Resilience we usually refer to this as detection. It's how do I take all of that aggregate data and determine something's going wrong or going right within the ecosystem. And this assessment isn't necessarily a split-second decision. When you start talking about prognostics, where you're trying to predict something's going to fail before it's going to fail, you might have assessments that take days, weeks, months before you actually get a result. But then you also have real-time things where if something fails, you need to do something immediately. And that leads to mitigation. Mitigation is really about how do I mitigate things that are reducing the safety factor within the airspace. A lot of times in manned aviation, there's humans involved, but as we get further along, I think everybody's talked at this conference about the need for this to be more automated. So this diagram comes from the NASA ISSA ConOps working group, who's just started looking into this problem in more detail. Everybody probably knows the UTM diagram there on the left, but what's really the key here is that these monitor, assess, and mitigate capabilities are going to be needed across the ecosystem, not in just one giant monolithic place. Particularly when you start talking about, and I'll talk later about the proprietary data nature, the individual vehicles are going to have to be able to do these things with their own sensors and on themselves. The GCSs, ground control stations, are going to have to deal with this. There can be supplemental data service providers or USSs that all have elements of this in-time system-wide safety assurance. So how does this relate to contingency management? Kind of what this panel is supposed to be about. Well, contingency management is all about what you do when something goes wrong. How do you deal with off-nominal situations that the system is likely or could encounter? Whether these are faults or errors or adverse conditions like weather or spectrum interference, or just some emergent behavior that you didn't actually design for. And so here I've listed a few objectives and considerations that, as we've been developing contingency management and graceful degradation techniques, we've really been looking into. The first is emergency or efficient contingency deployment. How do you deploy these contingencies when something is detected? And again, the contingency management is really the mitigate step in the monitor, assess, and mitigate. What do you do when, how does the system or the operator react? How do you deploy these contingencies? They have to be identified, but then a lot of times there's a human in the loop. What information does that human need? What kind of situational awareness? Can they override an automatic action the system's taking? Or can the system automate the entire reaction process and maintain some level of safety? The robust system architecture. Here, what we haven't really seen in UTM with the federated nature is an overarching system architect, somebody that's looking at the whole system, doing the systems engineering, the fault hazard assessments, the failure modes and effect analysis, looking at graceful degradation across the ecosystem, looking at how to keep everything fault tolerant and remove single points of failure. So putting some of those concepts into the system, I think, is going to be key. Maximizing system uptime and availability. Here, anytime the system's down, people are going to be losing money. Commercial operations aren't going to be occurring. Drones aren't going to be out there doing things for good. You know, we just heard from DJI about all the great things drones are doing. And then the public is just going to lose trust in the system if things are constantly executing emergency procedures and things just are brittle, they're not working correctly. An element of this is localizing and isolating problems. We really want to affect the least number of operators or users as possible when something goes wrong. We may not want an operator on one side to be affected by a problem occurring over here. We want their operation to continue as normal. But then the operator where there is a problem, we need to be able to deploy some contingency that remains a safe level within the ecosystem. And then with contingency management, we really want to get the system back up and running to full capability as fast as possible. This was a particular pain point with the US Army system. We actually had procedures in place for maintenance. And so once a problem was identified, it was fairly easy and straightforward to fix. The problem is when you have all of these different organizations involved, actually debugging these complex federated system of systems becomes challenging. You have one organization says, oh no, I looked at my error logs, everything looks great. Guy over here, yeah, no, everything's good on my side. They're both doing one of these, and you still have a problem, nobody fixed anything, your problem didn't go away. So we're looking at things like automated root cause analysis and auto recovery and repair capabilities. And I think the industry not hitting these objectives so far is really starting to show. We really are in demo mode, is kind of how I like to say it, where we get 35 tries to showcase some capability once, and then it's a lot of pack up and go home. That same capability doesn't have to run day in, day out. Doesn't have to have users running on it constantly, kind of pressure testing it, making sure that it runs in all the kind of conditions that could potentially occur. But I don't think that this is the silver bullet. We've talked at this conference about a lot of things that are happening right now with remote ID, with the trust framework. All of these elements play a role into the safety of the system. But I do think that without meeting these objectives of contingency management and ISSA, you're never going to get to operationalization, which will lead to the commercialization of the industry. And obviously, there are some challenges involved. With manned aviation, you have an operator, you have a pilot, you have a human. Humans are very good at taking their experience, their training, and then making decisions based on limited information that they may have. They're good at being able to filter out information that may not be right and looks a little fishy. Machines aren't great at doing that yet. Designing for every edge case is not usually feasible. And where autonomy will probably come into play as we move forward, that technology really isn't quite there yet. You have this federated and proprietary data element that I think kind of go hand in hand. All these black boxes are putting data into the ecosystem and making safety critical decisions based on the other data that's out there, without any understanding if that data is good, if it's latent, if it has integrity, if the black box sending it the data is healthy or working, or even is the right black box, which goes into the trust framework. And then safety levels, and this is kind of my call to action to this group, is that the safety levels have not really been established by the civil aviation authorities. We know with our experience with the FAA that they're probably not going to let these scaled, complex, beyond visual line of sight operations occur without these in-time system-wide safety assurance capabilities, but they've not yet asked for them. I think that as the authorities ask for these same type of capabilities, and the industry will start bringing them to the table. Which leads me to what we're doing. I think identifying these challenges is kind of an academic pursuit. What we've done is actually stood up a company to address them. So we've built the Resilience Framework, which is our fault recovery and isolation health monitoring framework. This framework provides a platform that monitors the health and integrity of the system, has a dashboard to allow the system maintainer or system administrator to understand the situational awareness about what the system's doing, how it's reacting to various faults and failures or adverse conditions that are detected. We monitor the system components, we mitigate failures, and we detect the various faults that can occur. We integrate everything in the ecosystem. We're looking at the sensors, the radar, the weather sensors, the comms, the C2, the backhaul, and all the web-based software and algorithms that all go into the entire ecosystem to really provide that safety level that's going to allow these scaled operations. And our goal is to maintain the system uptime and availability and allow the system to operate through the faults, failures, and adverse conditions that will occur in the real world. Love to talk to anybody more about what we're doing, and thank you for your time. Appreciate it.
Thank you very much. I work with civil aviation authorities in the traditional world, manned aircraft, air traffic controllers in control towers, and with some of this stuff, their head's going to explode, so we're going to see if the civil aviation authorities can keep up with this growth. Thank you, Andrew. My next speaker this afternoon is Dr. Kin Huat Lo. Dr. Lo is Principal Investigator of TM UAS Program of the ATM Research Institute. He's a Professor at the Nanyang Technological University in Singapore. Dr. Lo. And don't forget to send questions in on the website, because there's going to be plenty of time for questions.
Thank you, Chris, to remind me about the Bangkok. In Singapore now it's 3:45 a.m. This is the time I will dreaming my future. Yeah. First, thank you for the committee to invite me here and to give me have a chance to talk. I always look for the drone neighbor every year here, and I can see a new old friend, and also the new friend. Always try to learn something from here. Today, I like to talk about, as a professor in the university, I like to talk about contingency management of urban, because it's Singapore UTM, based on the airspace context. And basically, that's not my work because I'm a professor. So I have a wonderful team, Mr. Bi Zhao and also the Ming. And talk about UTM. So the objective of UTM is to manage the traffic of a multiple UAV operation safely and efficiently. And capabilities of UTM include the inter-operation information and allow also risk assessment and mitigation. I still remember 2017 first time. That's a wonderful event. And I actually first time to present the modular UTM framework. And now, this year, we talk about contingency management. And safety is always important. That's why this is double layer to make sure everything is safe. So today, again, as a professor, we don't provide the solution. We come out the framework. I will not show you any equation. Talk about contingency management. I like to put into two main areas, UTM, because now we are talking about drone enable, UTM contingency. And it's actually talk about pre-flight and in-flight. And even for these two areas, you're talking about many items. I don't have time for that, but you can always talk to me after the meeting. And I'll also talk about ATM because you come to UAM, ATM is there, and for that, I actually talking about airspace and airport contingency. There's a few items to talk about too. And when we talk about risk level, I like to link to the likelihood and severity. When I say likelihood, because it's a qualitative rather than quantitative, it's not a probability. It's a chances that an undesired incident will happen. Severity, it means the damage caused by an undesired incident. So based on this, I can come out something called low risk, medium risk, and the high risk. And this is based on the so-called relation between likelihood and severity. I want you to take note of the color. So like I give you a different scenario, talk about open air space. This is green region. You can say that you can have undesired so-called incident, separation violation. You can loss of communication, loss of control. And when you talk about the urban airspace, now we go to orange region, and you still have a separation violation, you have a loss control, but now you're talking about higher severity. And come to the, recently there's a lot of things happen in the airport area, and from here you look at so-called red color, I believe that's a red color, and you also talk about same undesired incident, which is a loss of control. So now give you an example quickly, and there are so many incidents, but I use a loss of control. And you can see that it's a low risk. City and airport, you actually talk about medium risk and high risk. Even the same incident, you actually, because of different area, the risk level actually consider differently. So right now I'm talking about the step of a contingency management. So what I'm going to do is, the step is you need to identify the so-called undesired incident, and then you can decide what kind of contingency should be taken. And then you talk about assessment, and that will be associated to the risk level and the type. And then you're talking about mitigation and the task carried out to resolve the contingency. And the last one, you still make sure everything okay, reassessment. I just want to see, I point to the right one. Central UTM contingency management, because you may involve a UAS, you may involve a drone unit, you involve an operator, and it's quite sometimes you may involve an airport area, then the ATM, airspace need to come in. And come to urban, quite often you need to talk to the third-party agency involved in this agency so-called measurement. So you have this centralized contingency management. And what happened now is a very simple example. You're talking about contingency deployment. You have identification to identify what type of undesired incident and talk about what kind of level of contingency need to apply. And then you do the assessment. And finally, you're talking about mitigation to solve the problem. But you're still not happy yet. You need to actually reassess to make sure everything's solved. Otherwise, quickly another action had to be taken. So right now, for this today, I actually try to come out not solution, rather a framework of a UTM, ATM contingency, and talk about different category. We also talk about the risk level linked to the various undesired incident in different airspace. Because even talk about same situation in different airspace, your risk level will be different. There are some questions remain. I hope that we can talk about this during the Q&A. How to evaluate, quantify the effectiveness of contingency? There must be a certain calculation. How contingency will affect the airspace? And the second thing is always the issue. Which party should be responsible for the contingency management? And we always, the so-called the action for pre-flight procedures and measurement will be useful if we can do the right thing. That will make the contingency management more effective. So I thank you very much. This is my email. You can always write to me. I always check the email. And I just want to highlight, I'm the only professor in this panel, and what we do now is basically is R&D. But that's why I like to be here always, to talk to different people, different stakeholders, to actually learn, to improve the work, and to make my result, my project relevant. And really thank you, also CAS and the NTU, Because of that, I will be able to make the trip here. Thank you very much.
Thank you, Dr. Lowe. Hey, just a question. Can you put your hands up here? How many regulators are there in the room? Just want to see how many regulators are. A fair smattering. Okay, thank you very much. Thank you, Dr. Lowe. That was excellent. And we come to our last speaker for this session. And this is Mr. Daniel Garcia Monteavaro. He is Head of Drone Business Development Department of ENAIR in Spain.
Thank you. Well, I have a challenge today because I'm the final finalist in the after lunch session. So I will start with a question. What is the difference between contingency and emergency? That most of you know the answer, but well, I think that is very instructive. So first of all, after we have a threat or an event and the barrier as mitigation is not enough, we can have different contingency plans, right? What is a contingency? Contingency, the situation is still under control, okay? That is what this talk about. And after that, we have the emergency, no? And after the emergency, we close the eyes, and it's the divine providence. That is something that we cannot control, okay? But it's something to take into account. Okay, risk assessment with UTM. SORA has been already said that there are main issues detected with SORA nowadays that is fantastic for operations, at least in Spain, is the principal safety assessment, but does not address the risk for multiple drone operations that fly simultaneously, and the UTM is barely considered, but it's normal because it's in the initial steps. So there is a need for evolution or of SORA or a new risk assessment, similar to, for example, Medusa in the Chorus ConOps from CESAR. The UTM risk assessment must include mitigations. This is something that is already been said by Nico, that it has to prevent collision between unmanned versus manned, but also between unmanned and unmanned. Ground risk with U-space services has to be used, as for example, the example from Peter for the density population is a good example of a ground risk that can be introduced in the UTM risk assessment at the moment. Incursions into no-fly zones with airspace infringement. And when defining contingency trajectories, it's important to have a quantitative risk approachment. So let's talk about contingency and emergency of UAS. Loss of link, loss of engine, loss of control, loss totally or partially of GNSS, loss of separation that leads into the tactical deconfliction, loss of ownership, loss of power. So what do we do with this situation? What are the contingency plans? Well, drones can have vision-based navigation, inertial navigation systems, opportunity signals, V2V communications, flight termination system, but all these requirements increase the price and the equipment that has to be on board. So it's needed and very important to play the UTM a main role in contingency management. So talking about contingency in UTM, what happens if the UTM service stops working or it's degraded? So the system has to be very robust and high continuity of service. And an example of having a mixed solution of liabilities, because cannot be everything in the UTM system or in the drone system, but as is shown in the graphic, if the UTM system, tactical deconfliction, for instance, doesn't work properly, we have the contingency situation of the V2V communication. I'm going to talk about Galician Skyways. It's a project that is in Spain that is from Boeing. In the north, it's a regional project, and ENARI participates with Boeing. And one of the use cases is the loss of link. So the ground control station in the normal operation is going to be updating with the drone a contingency trajectory logic. So this contingency trajectory is going to be updating all time. So in case there is immediately a loss of link, that contingency trajectory is going to be known by the ATM system. But this is not UTM. In a second phase, we could put the same situation, but the UTM would be managing this contingency situation. So the UTM would contact to the ATM system as a single point of truth. I'm going to talk about other project that was introduced in the other panel this morning, and it's Domus. That is, the leader is NIRE with other 16 companies as a project. And the architecture is based in a central platform with critical services, and the connection between the ATM UTM interface is done through this ecosystem manager, and the privileged users like military or law enforcement is done by this central platform. And below, there is an open market competitive of US-based service providers, and the drones connect to them. So in this project, how was the emergency management done? This is the same situation, the same players, but with the US-based services that maybe it's a little tricky to read it, but the emergency management modules are in red now. So although the operators and the drones have their own contingency situation, the USPs have their own contingency procedures. And if that fails, is the emergency management of the ecosystem manager, of the central platform. So there are different steps to avoid any threat. This is an example how the emergency management was carried out during the flights. On the left, you can see messages that come from SMS or WhatsApp or mails, for example, it doesn't matter, of loss of link situations. And on the right side is an example that when manned traffic went below the very low level limit, create a geofence, and that geofence sent alerts and alarms to the drones that were close by to stop the missions. About loss of separation, the contingency of loss of separation, it was managed by the tactical deconfliction and geofencing module. So when we had these two flight plans, these original flight plans, and one of the drones, the orange one, left the area, the tactical deconfliction module that you can see on the right side started to give alerts to both drones to deal with the situation and to give different messages, like ATICAs, okay? And, well, as it was said previously, safety is important, right? But it's not only the objective, it's important the way to achieve it. So, as Mildred from Boeing said yesterday, at least twice, safety comes always first. So it's pointless to have a very good system that provide US-based services if they are not reliable and can deal with all emergency and contingency situations. Thank you.
Oh, we've stuck very well to our time. Thank you very much, Andrew. Very good presentation. Thank you. Now, I've got a couple of questions that have been brought to my attention via email. So if you have any more questions, please bring them forward. But I'll start off with a couple of questions here, just to get people thinking. And my first question is for you, Peter. You provided some very interesting information and actually challenges in respect to calculating ground risk. What about reducing airspace encounter risk?
So we're doing some similar work in that regard, and it's challenging. There's a small group of us within JARIS Work Group 6 that are looking at quantifying air risk, and you can do that in a number of ways, using historical track data from really any surveillance source or ADS-B. There are a number of open questions about how much data do you need to demonstrate something. We're starting to hone in on that. You need relatively little data to tell you that airspace is busy and congested and likely to cause a collision, and you probably shouldn't be there. There are provisions within SORA that if you can demonstrate airspace occupancy rates below 10 to the -4 or 10 to the -6, then you can get an air risk reduction. But demonstrating that with data potentially requires a really large amount or some very careful statistical analysis. So validating those methodologies is going to take a little bit of time, but it's something we are working on. So we've taken a lot of ADS-B track data, binned it into little 100-foot slices, and gridded it into very small grids so that you can visualize this and potentially even plan a route to avoid those high-risk areas.
I think that sounds very, very interesting. Do you think the regulator's going to keep up with you? When you go into a meeting in these capital cities and you talk to the regulator, and at the moment they're struggling a wee bit at the moment with, let me just choose an aircraft type, Boeing 737 as an example. They're quite busy. A lot of civil aviation authorities are not funded wonderfully. So how do you start that conversation off without scaring the living daylights out of them?
I think we're working on some visualization tools to make it a little bit more intuitive, and that's a start. It does take some time to talk through a new concept, and certainly if we can find the right technical expert within that regulator who can dive deeper into the methodology, the equations, the processes, that can help give that assurance and trust as well. Because this won't work if the regulators don't accept the approach that we come up with, including within JARIS.
Okay, thank you very much. Question for Andrew. You mentioned that the NASA in-time system-wide safety assurance ConOps working group. Can you tell us more about that group and how it aligns with other groups out there?
Sure. So that recently kicked off. NASA's really trying to get their hands around how does this play into the ecosystem with UTM, with UAM. They're really looking at the long goal of UAM and these larger, higher risk operations and how these things scale out. And I guess the answer to this question is a call to the group of what organizations out there need to start looking at in-time system-wide safety assurance. You look at the roadmap of how do you get from here to this operationalized system, and I think that those capabilities are between here and there. And I don't think they're really being addressed in groups like RTCA or ASTM or potentially even the JARIS working groups. So I think that we're trying to raise awareness of what NASA is doing, and NASA at the same time is trying to understand how they fit in to the other working groups that are going on around the globe.
So is there something more that ICAO can do in respect to allowing for these groups to communicate better? Or, you know what, in ICAO, we could come up with some guidance, or we'd be aware that another group has guidance available, and we could produce a manual. It'd probably be approved in about 2 years' time. And nothing against ICAO, if anyone's listening. I was just saying, is there mechanisms that we should be stealing from other industries in terms of collaborating and getting the information out there so that all 193 member states actually have the opportunity to be familiar with these processes and moving forward?
Yeah, I think my experience with the FAA, and I think this isn't anything against the FAA, but there's a lot of bring me another rock, and I think that's around the world with civil aviation authorities. And I think what would be really helpful is a roadmap. What are the rocks? We talk about, remote ID became a big rock. The trust framework became a big rock. What's the next one? What's the next one? Let's try to identify those rocks and work on them and understand that, once we have remote ID, UTM isn't done. We don't have a scalable UTM system with a remote ID solution. I think that would be a useful thing to start saying, okay, well, now we know some of the barriers in our path to get there. And again, the system reliability and robustness isn't the only thing. But it certainly is one of the things. I think that these capabilities from the ISSA perspective are in that path.
Thank you. Thank you very much. And I just want to ask a question of Daniel. You were talking about the DOMUS project. Can you give me a wee bit more information, please, on the emergency management system and the extent it can mitigate the loss of link.
Oh, the loss of link.
Yes.
Yes. In Domus project, we have 3 different trackings at the same time, the tracking of drones. The telemetry from the USB that comes from the ground control station. Telemetry that comes from kind of hook-on device or dongle or add-on on the drone that is independent of the ground control station and the telemetry of the drone, and a multilateration that comes from the SIM, from the cell network communication. So we have 3 trackings that comes to the ecosystem manager, and when it doesn't detect the telemetry, but it detects the other tracking, he knows where it is, and creates a geofence around the drone and send alerts to other drones so other pilots receive the message that there is a loss of link situation around.
And one other thing that came up in one of your slides was concerned mitigations in relation to the loss of GNSS. This is becoming a consideration now around the world. It's probably considered now more of an issue than it was probably 5 years ago. It is common now to see NOTAMs issued advising manned aircraft anyway to caution the fact that GNSS might be disrupted. How does it affect your industry in respect to UAS or drones specifically? Does that change the equation?
Well, I'm not drone manufacturer, but for example, they should have redundancy in different GNSS systems, not only GPS or the Galileo, or Chinese, or Beidou, or GLONASS even. I think that this would be a good solution. But I think the future is, or at least what I have read, is all related to inertial navigation without using maybe in the future GPS or even visual, because there is very advanced all the visual recognition and to know where you are without using GPS situations. So it can be a solution.
Nico, do you want to add to that?
Well, what I wanted to say was, does it work?
No.
What I wanted to say is, if we lose GPS signals, I've been a pilot. If you lose it, you still have your contingency inside the aircraft. You have your beacons on the ground that give you a position. You have your inertial system that gives you a position. But it's not as good as it was with GPS. If we are doing drone operations in urban areas, you can have some contingencies like inertial systems, but it's not as accurate as it is with GPS. So you lose a lot of your separation because if you're only 5 meters away and then close to buildings or close to others. So we have to really look into what the problem will create, what problems it will create if we lose GPS on drone operation, or even on urban mobility. This is really something that we have to look into it. And it's good that we have multiple systems, but also the drones should be able to receive multiple systems and not just one frequency.
Okay, thank you. And just while you've got the microphone there, do you want to add to that?
I can add to that a little bit. I think there's an element of graceful degradation that goes into that. So if you have less of an understanding of where you are, your system should adapt to that by saying, well, let's avoid things by a larger distance, right? So I think that just having the contingencies of redundancy. Redundancy is often expensive. There's a lot of swap involved, particularly when you're on a small craft. So if you can have an ecosystem that can actually degrade gracefully and adapt to some of these things going wrong, I think you can reduce some of that hardware redundancy, reduce some of the swap to allow your UAs to do the mission they're on, rather than be full up of equipment just to manage every contingency they must run into.
So in terms of, and I think it was Andrew that talked about contingency management and localization and isolation of problems, what is the method of sharing that information across the industry? And I know some of this information is proprietary, but some of these solutions on occasions will be the mechanism that allows for this industry to survive, actually.
So I think right now a lot of the interfaces needed to actually do contingency management don't exist. It just basic things like fault, failures, mode, version, status, state, things that, what are you doing, and are you healthy? Those interfaces haven't been established in the UTM ecosystem. I think there's going to be on the regulators to say, here's the information that you need to share with the ecosystem. And part of that is identifying these graceful degradation schemes and how that's passed around so that people know, okay, this component's not doing what it should be doing. Let me cut off that feed and maybe go on to an auxiliary feed or do something different within the ecosystem that'll allow you, again, to adapt and degrade gracefully and not have these cascading failures, or to be able to cordon off don't fly in this small area, let's throw a TFR or UVR over that area, and then continue operations everywhere else as normal until we get that thing fixed.
Not easy. I have a question from the floor here for Peter. So I don't know if this is an enemy of yours, Peter, or not, just to put you on the spot.
Let's find out.
Given the proliferation of drones, do you look at the aggregate risk from all operations, not simply a risk per flight hour, but the risk for all operations?
So to do that, you need to know something about the operations that are happening around you. And this data doesn't live in a place that's easily accessible right now. So each individual USS probably is keeping some information about their previous flights. Maybe they keep it for an hour or a day or a year. That's not standardized or required by most regulators yet. And that information's not easily available to other entities, or if we wanted to build a data service to capture all that, there's not a way to fuse it. Remote ID is not implemented yet. And there needs to be a little bit of work before we can use something like that as a UAS surveillance capability. So the short answer is no, we can't do that yet. The longer answer is we need the data to be able to do it. It's not flights aren't happening uniformly, but it's also hard to say exactly where they're concentrated right now.
Thank you for that. And actually, I'll go back to you, Nico. I was just wondering, you have a wonderful source of information from your part of the industry of many ANS providers around the world. Do you have mechanisms within Kenzo whereby you can collate and coordinate a global response from your members to participate in this discussion? And how do you do that within Kenzo? Do you have mechanisms for making sure that the membership can get those views onto the global stage?
Well, we have a benchmarking working group, a global benchmarking working group, where we try to get as much information from our ANSPs as possible, and that make out of that a global view, either on safety, either on efficiency, or on traffic that we have. What people don't always realize is that the sharing of that is so important. So a lot of information is still restricted because people don't want to share too much safety information, too much economic, too much traffic information. Especially in what we now see in the drone UTM area, we have to start looking at it as a global system where everybody has to work together to get it on to work. And the sharing of data, having data available to make good risk assessments, to see what kind of contingency planning you have to make is very important. So within the ATM industry, we're doing that, perhaps not sharing it enough, but we're changing that as well. But for the start of this UTM, we have to look less competitive, but more how can we make this work now in a safe, efficient way that we get the public to recognize it, to see that it can be safe, and then get it on the ground. Otherwise, it will be not going where we want to go.
Mm-hmm. And is some of your members struggling at the moment in terms of new procedures, new procedures, basically within the air traffic control service? Their how has this impacted their safety risk assessment that they've been familiar with now for a good 10, 15 years? Now they have this new challenge or risk that they have to assess and mitigate against. How, is that causing them to stay awake at night?
Some have problems because of that, because the resources or the lack of knowledge or perhaps not yet the operations that are there. The good thing about international organizations where all the people come together is that they share their information and then they can work together on the information that a big player in this has and share it with the others. And that's what we do. And that's why we have a UTM task force where we work together, industry, our associated members, but also ANSPs, come together to see what kind of problems do we have, what kind of troubles are there ahead, and how can we solve it.
Okay, thank you. And another question from the floor is not directed at anyone, so you're all welcome to attempt to answer. In the real world, it starts with potential for dropped and latent communication links due to interference, sometimes unexpected, sometimes malicious. How would a centralized UTM continue to provide safe separation from other aircraft, UAS, buildings, and the population? And he goes on to say, should the UAS have a backup mode to deal with the loss or lag of a centralized UTM?
I think it's one of the things that I said before with the risk that we should not look at one problem, but at a big systems failing. Yes, it should be there. How do we do that? I think if the system is failing, then there should be in the drones, in the operators, if it's piloted, if it's unpiloted, it should be automated. There should be systems that everybody goes underground to a safe place until the problem is solved, as we did after 9/11 with the whole aviation system, which is the normal world. We have to have something in that we conceal it for that moment and start building afterwards again.
I think it's useful to think of the way we deal with this in air traffic today. There's not a single way that we deconflict. We have a whole separation stack. We have altitude separation based on direction of flight. We have SIDS and stars and one-way Q routes and T routes. We can translate a lot of these concepts to UTM. We need to do some work and some experimentation to figure out the right way to do it. You can minimize some of that through those structures and procedures. You can further minimize it by doing pre-flight strategic deconfliction so that before you take off, you have a flight plan that with some confidence, you're going to avoid conflicts with terrain, geofences, other aircraft. If that tactical deconfliction service somehow breaks down or has some lag, one, we should know or predict what that is. If it's 95% of the time it works or 99%, and build our deconfliction buffers based on that. And then, of course, we need to have detect and avoid either on the vehicle or through the ground control station to be that sort of that last barrier there. So it shouldn't be something where a single failure results in a mid-air collision. That needs to be a really cohesive set of capabilities.
So this next question actually falls into the same sort of stream, and I'm noticing some of the questions are similar on this one, and this one is from an old friend of mine. Do you foresee standardized contingency procedures, or does the nature of the different operations and flying environment make it impossible to achieve?
I think I can take that a little bit and relate it to the last one. I think that there's, what about or what happens if X occurs, and X could be, any number of things that can go wrong. And you talk about standardizing. I think really it's about doing the analysis of what can go wrong, what effects does that have on the airspace, what effects does this can have if there's another craft nearby, what effects does it have in an urban area, right? You kind of have to take the actual operation into account. But I think you can have some generalized or standardized operational environments there. And then what are the controls? How do you reduce or mitigate the safety level of this effect? And so at least when we look at the the ecosystem or the whole industry, just the systems engineering element it hasn't seemingly been there, or if it has been, it's kind of stovepiped into various organizations. And so I think that then in ATM, there's common methodologies to answer these questions that have been developed and adapted, and they just haven't been applied yet.
Go ahead, Nico.
I think contingency planning is based on the risks. The risk is based on this sort of operation. So yes, you could have some big contingency planning coordinated and be ready, but every contingency planning should be based on the specific risk of the operations, of the environment, of the weather, of the amount of traffic, and it's a variable. It's not a static thing. It's variable based on risk, based on. So yes, there should be baselines on that you should have contingency planning. Yes, there should be some big contingency planning, what everybody should take into account when there is a big failure, but the rest should be very variable based on the risk of the operations that you have at that time.
I'd just like to add, I'm not sure we want to standardize contingency plans, but we do want to standardize how those contingency messages get relayed between USSs and other UTM services and the ATM. We can't allow ambiguity about what a vehicle is going to do when other USSs or an air traffic controller has to actually know what's happening and make a plan around that. So that's where protocol standardization can be really beneficial.
So one thing I notice, and I'm picking this up from a question, more of a statement than a question actually, that one of the ways we've solved problems in the past is that collegiate social relationship between air traffic controllers, pilots, ground staff, dispatch, whether we all drink in the same pub or whatever it might be. But me as a former air traffic controller, how do I meet this community? Where do they drink? And so I'm just wondering, maybe on Facebook, I don't know, but where is that place where that debate on the ground can occur? And remember, in some countries, this is difficult even in the best circumstances. There isn't even an environment, quite frankly, where even pilots and controllers get the opportunity to gather and actually find solutions just through communicating information. What's the mechanism in this new environment where the different players on a local level can get together and talk about it?
I'm not sure that mechanism exists all the way. I think the AUVSI local chapters are one potential source that's really beneficial, but there's a precondition for those discussions to happen and be beneficial, and it's that everyone has to be in the mindset of admitting that something didn't go quite right and being willing to talk about it and maybe catch some criticism and then go on to improve your operation. And that safety culture doesn't quite exist yet for a lot of UAS operators. And to the regulators in the room, the event reporting requirements are minimal, and I'm not convinced that even those basic ones are being adhered to. So there's a couple of things that would help to move that along, which is requirements to report not just when your drone kills somebody or causes X dollars of damage, but those more minor things of, I had a C2 lost link for 30 seconds and I recovered it eventually, but that wasn't supposed to happen, and I didn't have a contingency plan. We need to know about those kinds of things and learn from them and improve our processes, and then have those conversations.
Well, I think this is a forum where we can meet. This is something globally is good, but we should also have it regionally and perhaps even nationally. There are mechanisms like collaborative decision-making processes that states and CAAs already have that they could perhaps expound for UAS operations. The mechanism is there, you just have to need the right people in there and to make sure that you have the information. And reporting of any problems is something that has to go into that culture. We have a safety culture in aviation. It should be the same safety culture in drone operations.
Okay, thank you. We're just fast approaching the end of our time now, and I'm sympathetic there for Dr. Lowe. It's almost 4:30 in the morning, and so is there anything that we haven't covered? Do you think that needs to be highlighted for the audience that they need to keep in mind in respect to risk assessment and management?
Yeah, finally I can say something. Just now I mentioned, even talk about centralized, decentralized, it depends on the type. the contingency also depends on situation. You cannot use one method to solve all. So the type, the situation, some contingency is only involve one or two parties. Some actually have to involve so many parties. So safety is always important. Just now Peter mentioned about pre-flight preparation. That's very important because in future the drone is autonomous. So you need to make sure everything okay. But to talk about DJI talk this afternoon, they are doing a good job. Compared to 10 years ago, DJI now is more capable. But there's a lot of things you can't actually do it. That's why you have something predict. You have something called contingency or emergency. Just now you say what's the difference between contingency and emergency? Emergency is always after when the contingency doesn't work. That's an emergency. Yeah, that's my definition. Recently, there's a case that a glider actually killed a woman, and the one fly the glider. I don't want to mention the country, the place. The one fly the glider is a professional. And he was there every year. But this thing happened a few weeks ago. It's because of the wind. It's because of wind situation. So there's a lot of things every time is okay. 99.9% okay. Just because that moment, because of weather, because of all this. So this is something, it's not an easy problem, but at least we can make sure 99.9% are safe. So basically, that is depend on the type and the mission also, and the environment. Finally, I can say something. Thank you very much.
You're welcome. You're welcome. Look, I'm going to leave it there. We're just about finished our time. I'd like to thank my panel. What an excellent group of presenters. And so thank you very much. And just before you applaud them, I'll just remind you that we're going to a coffee break at the moment, in a moment, sponsored by the Boeing Company. We'll start the final session of day 2 at 4 o'clock. Is that right? And the speakers for the next session are requested to be on stage at 3:55. So thank you, panel. You've been excellent. Very good. Very good.
Gentlemen, if I can ask you, button the jackets, please.
Who's standing next to me?